Hello and welcome back to Database Design Made Easy. It is time for the final part of this series, part 11, where I will talk about domain key normal form. And domain key normal form is a bit of an odd one out in the world of normalization, because where all other normal forms are defined based on dependencies, functional dependencies, multi-value dependencies, join dependencies, domain key normal form has a completely different definition, and that definition is based on domains, keys, and constraints. Now, before I give you the definition, let's talk about what each of these terms means. So, a domain is a rule of which values are allowed in a column. And if you look at implementation in relational databases, you will realize that a data type is effectively a domain, because a data type says this column can only contain integers, or this column can only contain string values of up to 10 positions. But a nullability rule is also part of the domain. Can this column contain the null marker or not? That's also part of the domain. And finally, a subset of check constraints are definitely part of the domains. Like, for instance, a constraint that says the value in the column percentage shall not be less than 0 or more than 100. That is definitely a domain because it restricts the values in a column. Now, technically speaking, not all check constraints are part of the domain, because a check constraint that says column 1 has to have a larger value than column 2, so it uses different columns in one check constraint, while allowed in the ANSI standard and in almost all relational databases, is not officially part of the definition of a domain. But if you look at what domain key normal form tries to achieve, I would say that let's look at them as well as a part of pseudo DKNF. Now, the second term, keys, is a term we already know. This means all the candidate keys that you found. So while dependencies are not literally technically part of the definition of domain key normal form, at least the functional dependencies are there because they imply the candidate keys. And then finally, the last term is constraint, and that is a different word for all the rules for valid data, or the business rules, as I like to call it. Now, with these definitions out of the way, the formal definition for domain key normal form is that every constraint must be implied by the keys and the domains. And this is also a normal form that doesn't look at just a single table. We have to look at the entire schema completely. Now, according to academic research, if a design is in domain key normal form, then it has to be in fifth normal form, and of course also all the lower normal forms. And I added a footnote because I have seen situations where to achieve domain key normal form, I had to add a computed column that basically is redundant and that does not satisfy all the fifth normal form rules. So those computed columns need to be accepted in the statement that DKNF implies a fifth normal form. Now, domain key normal form does not imply optimal normal form or sixth normal form. And that makes sense. Remember, the difference between fifth normal form on the one side and optimal and sixth normal form on the other side is how you deal with join dependencies that are implied by a key. And we saw that there is no difference between fifth normal form and optimal or sixth normal form if you look at what business rules are protected by the database. The only difference is how it is stored, whether or not you get those null values in your tables. But there was no difference in business rules. In fact, the sixth normal form version is a bit weaker when you look at what business rules are enforced. So that is why domain key normal form does not imply optimal normal form or sixth normal form. However, it's also not the other way around. Optimal normal form and sixth normal form are not implied do not imply domain key normal form. In other words, a design can be in 6th normal form and still not be in domain key normal form, whereas another design can be in domain key normal form and not be in 6th normal form. Now, why do we even look at a normal form that has this completely different definition? What is the practical relevance? Now, to understand that, let's return to those ingredients. So we have the domains, and the domains can be implemented by data types, nullability rules, and check constraints. So they're all declared on the database level, and it's the database management system that enforces them. We don't need to write any custom code to protect those rules, other than just that single check constraint if you need one, or that single null constraint, or that data type. Similarly, we have seen that candidate keys can always be declared at the database level as a primary key or as a unique constraint, or in some database systems with a unique index. And again, it's the database management system that enforces those keys. We don't need code. So if you are not in domain key normal form, then that means that there are some constraints that are not implied by the domains and the keys. Those remaining constraints still need to be enforced, and because we can't do that by domains or keys, we have to write code. It could be front-end code, or it could be back-end code if you use, for instance, a trigger in the database, or use stored procedures to do all your modifications. There are multiple places where you can have that code, but you need to write that code to enforce those constraints. And code equates to money, because writing code takes time, takes effort, and that costs the company money. Then you need to test and debug the code. And again, that costs the company money. Nobody will ever spend a lot of time to test whether your database system correctly enforces primary keys. You trust the vendor that this is done. If you write your own code to enforce any business rule, it must be tested and probably debugged if you find a mistake. And then after everything has been deployed to production, it still needs to be maintained. And again, that will cost time and effort. So code is money. Domain key normal form means that you lose that entire category of other constraints. All the constraints are implied by the domains and the keys. You don't have to write any code ever. That is the theoretical idea. But in practice, it turns out that domain key normal form is not always possible. So let's say that we organize a conference, we are busy with selection of sessions and speakers, and we care about DEI. So one of our business rules is that we want equal representation for all genders, and to achieve that, the business rule is that no more than 60% of sessions can have presenters of the same gender. Now, let's look at the schema that supports this. So if you look at the facts that you need to even verify this, then you know that you have a session table with a session column as the candidate key and a presenter column to store who presents that session. And you have a different table where you store the presenter and the gender. That would be the presenter table. Now, when you do this, then of course the presenters need to be existing presenters, so you also have a foreign key constraint that enforces that. At this point, a lot of the business rules are enforced, but not yet this specific rule of no more than 60% of the sessions can have presenters of the same gender. And there is a problem here because If you want to enforce this, then you need a check constraint on the presenter column in the sessions table. But that check constraint also has to verify the genders which are in a different table. And many relational database systems don't support a check constraint that goes to a different table. Technically speaking, of course, there's this distinction between the official definition of domain and the semi-official, more broadened definition. The official definition of domain simply can't do this because we can't enforce this by restricting the values in any specific column. We need a more complex check constraint, which already means it's not official DKNF, but if you extend it to unofficial, you still need a database management system that allows you to write a check constraint that also looks in different tables. Many RDBMSs do not support that. Now, you can work around that by redundantly storing a computed column in the session tables. You can store the gender there. Now, most DBMSs can enforce this rule, but of course we now violate second normal form by storing the column gender in the session table, even though it depends on a non-key column presenter. So DKNF allows that. If you allow for this exception for computed columns, it has to be a computed column, but it's still not a good design, in my opinion, because now you run the risk that someone maybe modifies that column unless you can protect against those modifications. A second problem with DKNF is that there are cases where it's perhaps possible but not practical. So let's look at an example where you say that we have a table of customers, but only those customers that are natural persons can have a birth date. Legal entities can also be our customers, but they are companies. They don't have a birth date. So we don't want to store any birth date for them. Of course, there would be way more columns in the real system. I'm just showing the relevant columns here. So we have a table of customers with a customer number column that is the candidate key, and then we have the customer type, natural person or legal entity. That would be a check constraint to enforce that only those two customer types are allowed, and then the birth date, and as you see, it is null for the legal entity to comply with the business rule. But we can't enforce that. Well, again, more complex check constraints can enforce that. We don't even need to look at a second table, but the official domain definition can't enforce this. And if you go to more complex examples, I didn't want to make it too complex for the video, but if you go to more complex examples, it's definitely possible to create situations where you can't enforce a rule that applies for only a subset of the population. Because that's here the problem. This business rule doesn't apply to all customers. It applies to only natural persons. And the typical domain key normal form solution for that is to say, hey, we have a rule for natural persons, so perhaps we should have a specific table for natural persons and store the birth date in that table and not as a column in the generic customer table. And then, of course, we also need a foreign key to ensure that every natural person has to be an existing customer. This looks a lot better. But like I said, it's impractical. Because what if we also want to store the type of business of every legal entity? Customer number 2 is an LLC. Customer number 1 and 3 are natural persons. They don't have a business form, so now we need a yet an extra table to store legal entity customers. What if we also have a business rule that a certain column is only tracked for LLC companies? Now we get a table that is a subtype of the legal entity customers. What if we have a column that only applies to customers with platinum status? that would be a different subtype that can be partly natural persons, partly legal entities, but all are platinum tables. So you get a wild growth of many tables that are all a subtype of another table, because in reality many business rules apply to only a subset of a group. So that's why I call it impractical. Also, let's return to the original version with only the birth date. It's not only impractical, it's also, in the current form, incomplete. Because this looks like a great design, right? But what if I add this row? The database will allow this. There is no constraint, no key, no whatever kind of rule in the database that prevents me from adding the customer number 2 in the table for natural persons. I know it's wrong because customer number 2 is a legal entity. The database doesn't protect this rule. So this is not domain key normal form. The constraint is not implied by the domains and the keys. So once more, we need to add a computed column. We need to add the customer type redundantly to the natural persons table. And at this point, we can now add a domain that says the customer type in that table can only be the value natural person. And now this domain, this check constraint, will enforce the rule that only natural persons can be in the natural person table, and hence the birth date can only be stored for that customer. All right? Well, no, we're still not there yet. Because what if I change this value here to natural person? Yeah, in the customer table I say that customer 2 is a legal entity. But in the natural person table I have customer number 2 and claim that they are a natural person. Again, the database will allow this, unless I have found a way to make this second redundant customer type column immutable. But if I don't, then this will be allowed by the database, and I have to resort to a similar trick that we also saw when we talked about Boyce Codd normal form, the unofficial and not technically part of the SQL model foreign key on an extra column. With this solution, now this modification is no longer possible, and I can't store customer 2 in the natural person table. Now it is really impossible to give a birth date to a legal entity. Now we finally have achieved domain key normal form for this universe of discourse. But what if the universe of discourse is slightly more strict? What if all natural persons must have a birth date? So now, with this small change, it becomes illegal to set the birth date of customer 3 to null. Well, a not null rule will of course achieve that. But what if I then just remove that row? How will the database prevent this? There is simply no way in relational databases, apart from writing custom code of course, but using standard rule domains, or even the widened definition of constraints, and using standard keys, there is no way to force customer number 3 to be in the natural person table. And think about it, if you would force that, then you also would have a data entry problem, because you can't add customer number 3 to the customer table before adding them to the natural person table. But you also can't add customer number 3 to the natural person table before adding them to the customer table. Deadlock. Deferred constraints are defined in the ANSI standard as a solution for that, but they are once more not implemented in many commercially available databases, so it is probably not a solution for you unless you are lucky to have exactly that type of database as your target database. So let's recapture. Domain key normal form means that every constraint must be implied by the keys and the domains. We saw that this normal form is often impractical and sometimes simply impossible, even with the widened definition of or interpretation of what a domain means. As such, I consider domain key normal form to be of academic interest only and not really of practical interest. So let's end this video and this series with an overview of all the normal forms. The most regular normal forms are listed here with arrows showing how each one builds upon each other. Now, most people agree that third normal form is definitely needed. I would go a bit further and say that fifth normal form is needed. Sixth normal form is not, and in fact, in some cases offers less protection against violation of business rules and is very impractical with current mainstream database systems. But fifth normal form is definitely what you should strive for. Of course, this list is incomplete because in between third and fourth normal form we find Boyce-Codd normal form, and in between fifth and sixth normal form we find optimal normal form. And then we have the rather weird ones like elementary key normal form sitting in between third and Boyce-Codd, basically just giving a name to third normal form schemas that can't do or that can't reach Boyce-Codd normal form. And then we have domain key normal form, which does apply fifth normal form with a small footnote, but then is a separate branch of its own, and also is of relatively low interest because in many cases you simply can't achieve it. So after all these videos, I would say definitely normalize until third normal form. You should absolutely do that. Then please also check for Boyce-Codd normal form, fourth normal form and fifth normal form. It shouldn't take much extra time because the situations where those normal forms can be violated are all quite rare. So in most schemas you would only have to check a few tables. And it's worth it because you can prevent many business rule violations simply by normalizing up to fifth normal form, and then you get those enforced for free. It's worth it. This concludes the entire series Normalization Made Easy. Of course, I still recommend that you watch my Pluralsight course, which includes that method to, in a very structured way, find all functional dependencies. It's a long course, but if you have the time, I would say watch it. That's it. Please like, subscribe, leave comments, and I will be back eventually on this channel. I'm going to take a break now and focus on other things, but I will be back with more videos. I just don't know which topics I will treat, but I hope to see you again later. Thanks for watching. Thanks for your interest. My name is Hugo Cornelis. I greet you. Bye bye.